Hello Precalc, this is 2.8, solving inequalities in one variable. Hello Precalc, this is 2.8, solving inequalities in one variable. So essentially what we're trying to do here is find when f of x, our function, is going to be greater than 0, aka above the x-axis, or if it is greater than or equal to 0, it's actually hitting the x-axis and also greater. So our answers could be a whole range of x values. So we want to find those x values that make the function positive, or if we're looking for less than, we want to find the x values that make it negative. And example 1 is a good problem to try. So we're going to let f of x equal x plus 3, x squared plus 1, x minus 4 squared. We want to find all the x values that cause the function to be 0, positive, and negative. So what I did first is I took each of these factors, because it's already factored, set them equal to 0. These are going to be our zeros. So I found negative 3. This one's only going to give us a positive and negative I, so we don't have to worry about that one. And positive 4. So if we think about like the x-axis here, this is called like a sign chart. We got negative 3, so we know we're going to hit 0 here. And we got 4. So it's also going to hit here. What we're going to try to find is what's going to happen to the signs in between and on the outside of these numbers. And excuse the work I've already done. I already recorded this once, and apparently my USB drive was full. So you get to hear it again. I'll try to go slow. So negative 3. We want to figure out what's going on to the left of this. So I'm going to pick a value that is less than negative 3. Let's say negative 4. So I'm going to plug in negative 4 to our original function up there. So negative 4 plus 3, negative 4 squared plus 1, and negative 4 minus 4 squared. And all we really care about is what sign we're going to get. So this first one's going to give us a negative, that's a positive, and a negative that's going to be squared is another positive. So we're going to have a negative, positive, positive. And what do you get when you multiply a negative, positive, and positive? Is you get a negative. So we know our function is going to be down here somewhere below the x-axis. So this is definitely where the function is going to be negative. For negative 3 to 4, I'm going to plug in 0. Alright, you can plug in 1, negative 2, 2, whatever you want to do. 0 is probably our easiest. So when you plug in 0, you'll get a positive, positive, and that negative 4 squared is still a positive. So this is going to end up being positive here. Right, and to the right, or greater than 4, I'm going to plug in 5. And we're going to get positive, positive, positive again. Alright, so we're negative to the left of negative 3. We're positive between negative 3 and 4. And we're positive greater than 4. Now keep in mind, I can't just say it's positive from negative 3 to infinity, because it hits 0 right here. Alright, so we got to make a union for these intervals. So negative 3 to 4. Union 4 to infinity. That's our positives. And negative is going to be from negative infinity to negative 3. Alright. You try exercises 1 and 2. And go ahead and pause the video. I'm going to do example 2, same video. Alright, so for this one we want to figure out when x, or what values of x is going to make this function greater than 0. And I want to start by finding the zeros, just like the last example. So start by finding zeros. Easiest way to do that would be to graph it. Alright, so there's that function in the graph. Alright, so we know we're definitely hitting at negative 2. We're hitting at 1, 2, 3, 4. And it looks like I'm hitting at 1.5 or 3/2, and I'm going to use my table to figure that out. Alright, so 1.5, so I want to start counting by 0.5s there, and we are. We got a 0 at 1.5. Alright, so that was negative 2, 1.5, and 4. Alright, so we'll get our sign chart again. And we got negative 2, 1.5, and 4. And we can pick out values again and start plugging them into there. Or we can actually look at our graph for this now. Alright, so to the left of negative 2, that's everything down here, we're going to be negative. Alright, between negative 2 and 1.5, the graph is all positive. It's all up there. And between 1.5 and 4, it's all negative. And from 4 to infinity, we are positive. Alright, so like I said before, our answer could be a whole range of x, and it is here. It's between negative 2 and 5. So the whole function is greater than 0 between negative 2 and 1.5, and between 4 and infinity. Alright. So let me give you number 11 and number 10. 11 and 10. So example 3 is a lot like example 2, except you notice we're not set equal to 0, or in an inequality not equal to 0. So we need to first move these terms over to the left. So we'll have x cubed minus 6x squared plus 8x minus 2 less than or equal to 0. We want to figure out where it's less than or equal to 0. Alright. So again, we find our zeros by graphing. Alright, so we got some little craziness going on in here, so let's zoom in. Figure out what's happening there. Okay. And we might want to do a little intersection, because this doesn't look like it's going to hit a whole number or a nice fraction we like. So let's go y2 is set equal to 0. That way we can do a second trace intersect. Alright. So to get this first 0, enter, enter, enter. 0.32 is fine. Alright, now go ahead and get this other one too. Second trace 5. Enter, enter, enter. 1.46. And I gotta zoom back out to get that third answer. Second trace 5. Enter, enter, enter. 4.21. And we're just going to come right back to that calculator. Make a little sign chart. Alright, so to the left of 0.32, that's down here, this is negative. Between those two answers, it's above the x-axis, so it's positive. Between the next two, we are below, we're negative. And to the right of 4.21, we are positive. So keep in mind, this is a less than or equal to 0. So having an answer of 0.32 is okay in this one. So our answer is going to be from negative infinity to 0.32 inclusive. So we have to include the 0.32. And also between these two. Inclusive. So we're going to include 1.46 and 4.21. Alright. I don't have a classwork for you to do on that one. So we're going to skip example 4. It's a lot like example 3. Example 5 deals with a rational function. So we have a function divided by a function. So this one is just a little different in that we have to include our undefined values on our sign chart. So we find our zeros just by setting the numerator equal to 0. So 2x plus 1 equals 0, 2x equals -1, x equals -1/2. And undefined is where our denominator equals 0. So undefined values, x cannot equal -3 or 1. So all three of these need to be included on our sign chart because there may be a sign change going on in between these. So we got -3, -1/2, and 1. Alright. So once again, we're going to plug in values to the left of -3. So let's plug in a -4. Alright, so on the top, plugging in a -4, we got 2 times -4 plus 1, that's a negative sign, divided by a -4 goes in there, that's going to be a negative. I wrote -1 again. And a -4 in there makes another negative. Why do I keep writing -1? Negative times negative, that's positive. Negative divided by a positive is negative. So we are negative right here. Alright, between -3 and -1/2, I'm going to plug in a -1. So we got 2 times -1 is -2 plus 1, that's negative. -1 plus 3, it's positive. And -1 minus 1 is -2, that is negative. So we got a negative divided by a negative, this ends up being positive. Alright, plug in 0, we got positive, positive, negative. So positive divided by negative, that's a negative. And let's plug in 2. So we'll have positive, positive, and positive. So everything there is positive. So for values that make this thing positive, so positive are going to be between -3 and -1/2, and also 1 to infinity. And x values that make this negative, -infinity to -3, and -1/2 to 1. I want you to go ahead and try numbers 22 and 25. So example 7 is going to be the last example I do for this video. It's a radical function, so we have a square root of x plus 1 in here as well as an x minus 3. So like always, we're going to find our zeros. We're going to get 3. And the value of this is going to make it 0 is -1. Now keep in mind we also have to figure out where this is undefined. So we cannot have a negative under the square root. So this has to be greater than or equal to 0. So x has to be greater than or equal to -1. So we don't even exist to the left of -1. Right? So our sign chart goes -1, 3, and then off into infinity. And over here we already know we're undefined. Alright, so let's plug in a 0 here. So we get a 0, minus 3 is negative, and we get a positive there. So negative times a positive, this is negative. And let's plug in 4. So there's a positive, positive, this is positive. Right. Keep in mind, if we did not think about plugging in like a -2, this would be a negative, and that would be a negative. So we get a positive over here, and that would be part of the answer, but it would also give us a negative under the square root. So we have to think about that, that's why it's undefined. Alright, so this is greater than or equal to 0. So we got to do 3 as well as everything to the right of it. So our answer is going to be including 3 and infinity. Right. So So I want you to try 29 and 30. And we'll talk about the rest in class.